Hey everyone, welcome to the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. In case you're wondering, we've got a bunch of really great interviews that I've had a chance to do over the last couple of weeks, so check those out. And of course, the weekly Space Hangout and Astronomy Cast are coming very soon. So stay tuned. Probably in the next couple of weeks, we'll start doing those shows again as well. All right, let's get into the questions. Canon Lucas. Hey Fraser, cheers from Chile. What do you think about the issue of the Blue Origin and SpaceX lawsuits? All right, so for people who aren't familiar with this, of course, you've got SpaceX, which has been launching the Falcon rockets, has launched the Falcon Heavy, is working on the Starship, and has won a bunch of contracts with NASA. They, of course, are the ones who supply some of the cargo to the International Space Station. They have been launching the Crew Dragon capsule, which has been taking astronauts up to the International Space Station. But NASA's working with a whole bunch of providers. And one of the future contracts that NASA did was they wanted to have a landing system for the Artemis missions. Instead of building their own lander like they did with the Apollo missions, they wanted to essentially purchase a lander from some outside agency. And they went to a bunch of providers, SpaceX, Blue Origin, Dynetics, I think they're called, and a couple of others. And in the end, they chose SpaceX, and SpaceX with a Starship. And so the plan, of course, is that SpaceX is going to launch a Starship into orbit, refuel it a bunch of times, fly out to the moon. It'll orbit around the moon and serve as a lander. So when the Space Launch System arrives with the Orion capsule to the lunar gateway, the astronauts will get out, and then they'll get into a transfer module. They'll go to Starship. They'll land on the surface of the moon and then come back up. And NASA choosing Starship was a pretty big surprise. And partly was because Starship came in, SpaceX came in at a much lower cost than any of the other providers. Also, it kind of has a ridiculous amount of power on paper compared to what the other ones were very specific, like just big enough to get the lander down to the surface and back up again. Maybe, although NASA was a little concerned by some of the math that was involved with the other landing systems. But while Starship is just this, is this monster, which has tons of power, tons of fuel, will be able to make multiple journeys down to the surface of the moon. And because of its reusable system, and because I'm sure SpaceX was willing to take a bit of a loss and is already planning to go to the moon, they were able to come in at a very low price. And so as part of this process to slow down SpaceX, Blue Origin has sued, and they've delivered an enormous document to the government, and it's sort of snarled up the process. And now the government is having to consider this legal process. And in fact, the NASA chief came out a couple of days ago and just said, like, Blue Origin is in every right to sue. And I kind of agree with that. Like, obviously, suing to get your way as opposed to competing to get your way is not necessarily the best way to conduct business, but it's just business. And so you try to use everything that you have at your disposal. And if that means lawsuits because you think that you are truly being treated unfairly by NASA, by the people who are choosing, then you're well within your rights to be able to do a lawsuit and have a chance for the government officials to look at it another time, for legal experts to consider the situation and find out if the case that you're making is legitimate. And so, it shouldn't be surprising that this is happening. And if the SpaceX case is still really strong, if the Blue Origin case is as weak as originally what caused them to not win this contract, then their case will be thrown out and SpaceX will continue on. But of course, Starship isn't flying to orbit yet. It's definitely not in lunar orbit. It is definitely not demonstrated that it can land on the moon and return back to lunar orbit. So there's a pile of hurdles. Of course, Blue Origin doesn't have a rocket that can go to orbit, doesn't have a lander that can land on the moon. Like, it's all hypothetical. And so now is the time to argue about this stuff into the future. And then on the other hand, you've got Amazon potentially looking to slow down what SpaceX is doing with Starlink. And it's the same thing, right? I don't think anybody anticipated that SpaceX would charge forward with Starlink so quickly, get so many satellites up into orbit, and build out the service before anybody else even had a chance to move. Of course, They've got the first mover advantage. They've got the rocket systems. They've got all of the satellites. They've got all of the infrastructure to be able to do this. If Amazon is going to be using Blue Origin doesn't have a rocket that flies to orbit yet. So it's quite a head start. And so if you're trying to compete down the road with what SpaceX is going to do, using the law is just one of the tools at your disposal. There's like a saying in the music industry, whenever there's a hit, along comes a shit with a writ, which sort of says, like, if you're successful, just anticipate legal action to try to slow you down and to try to, as another way to kind of wedge into what you're doing. So it doesn't surprise me. I think it's totally fair. And as long as it doesn't delay too much the whole process, I think it's a reasonable course of action for Blue Origin to take if they think they're justified. It's reasonable for SpaceX to fight, and hopefully in the end, the courts and NASA will make the right choice. Joe: why does telescope resolving power scale with size? Why does a larger telescope allow you to see fainter objects besides the light gathering power? Actual resolution? The trick with a telescope is it's all about gathering photons. And so the bigger the size of the telescope, the more photons you are catching, and then you're concentrating them into your smaller focus that you can then look at with your eyes or with a camera. And you can actually really experience this. Like if you have like a pair of binoculars, and you can get binoculars with fairly small lenses and you can look through them, and you can see objects that are more highly magnified, but they kind of look a little blurry. They don't look great. They look bigger, but they don't look crisper. But if you look through a pair of binoculars, like with really big lenses, like those astronomical binoculars that I use, suddenly the thing looks very crisp, very clear, very close. It's almost like you could touch it. And so when you look at telescopes, it really just is the size of the telescope, the reflecting surface, the refracting area, defines how many photons that you are catching, and then you are concentrating them down to be able to see these objects that are much fainter. So yeah, just size, just number of photons that you can catch. Darren Clark: if you interviewed Elon Musk, what direction would you take in your questions? Man, that's a great question. 5 years ago, I would have loved to have interviewed Elon Musk. I think it would have just been one of the most interesting conversations. It would have been super fun. But now I don't really care. Like, obviously, if him or his PR agency reaches out and they're like, hey, Fraser, let's do an interview, I'll be like, yeah, let's do it. That'll be super fun. But I think that there's too many unsung heroes in the space industry who are worthy of interviews, who we're not getting a chance to talk to and hear from them. For every Elon Musk, you've got Gwynne Shotwell. I would way rather have an interview with Gwynne Shotwell over Elon Musk. And then there's thousands of really interesting engineers at SpaceX, at Blue Origin, at NASA, at the European Space Agency, in Japan, who are working on very specific technical problems that are really interesting to me. And I think it's sort of like you get to a certain point and sort of the general overarching issues that SpaceX is facing, that Elon Musk is trying to consider, we understand them. Like, we know what his answer is about humans to Mars and the future of rockets and so on and so forth. But we don't know some of the more interesting, specific technical details. And I'm finding as I'm choosing guests to do these interviews with, I'm getting really quite excited about scoops. My favorite person to interview, and my interview today was exactly like that, where someone who is very knowledgeable, has lots of experience, is very enthusiastic, very, very well spoken, and is able to answer and explain very complicated issues, but isn't in the public eye, isn't worn out by doing a lot of interviews, and has some really fresh perspectives on things that we've never heard before. And I feel like that's my job, is to dig in. But I'm sure if I talk to Elon Musk, I would want to just go right into just nitty gritty about a lot of very specific questions that I have about flight hardware, about the way the missions would work, and some of the other ideas. So it would be kind of the same, in that I would just get in as much detail as I could about how things are going to work, what are some of the challenges they're looking to overcome, etc. So yeah. Luke B: when the US and China inevitably go to war, will the moon be a factor or no? I don't like the premise of the question that the US and China will inevitably go to war. I don't think the US and China will inevitably go to war. War is bad for business. And both China and the US, their economies are so mashed together that neither one of them would ever want to go to war. I think China definitely wants to be the leader in technology and science and economic progress, and the United States wants to be the leader, but I think both groups understand that you don't get to be the leader by going to war. That just causes destruction, both to obviously human lives and your economy. So I don't feel like they're going to inevitably go to war. I think China and the US are going to use every other trick in the book that they can to get ahead. But I can't imagine it will be a full-out war. And I don't know whether full-out wars are going to happen anymore in this modern, you can have cyber war, you can have information war, propaganda wars. We saw what happened with Facebook and social media and things like that. So I'm that's how wars seem to be fought today. But if they did, would the moon be a factor? No. I mean, the moon is not any use militarily. I mean, it's really far away from Earth. If you want first strike capability, you put your nuclear missiles in orbit, and then you have them orbit your enemy countries. And then when the war begins, you just launch the missiles and they explode within a minute. So it doesn't make sense to try to put stuff out onto the moon. So no, I can't imagine any military purpose for the moon. Prince Charming, do you think that space elevators are feasible? I think space elevators are like borderline feasible. This is the idea, of course, of taking a ribbon of carbon nanotubes, attaching it to the surface of the Earth, reeling it out to beyond geostationary orbit, and then you have an elevator that just climbs up this ribbon, getting to orbit with a fraction of the complexity, danger, speed, power that it takes for a rocket to do that same journey. But there are a pile of downsides to space elevators. The biggest one, of course, is that we don't have the material that could possibly do this. I mean, we don't know. I mean, maybe theoretically carbon nanotubes could do it at some point in the far future, but there's lots of other problems with it. The climbing, just having a spacecraft that could climb using solar power is actually really difficult. And they'll be going to be really underpowered to be able to climb up the tether. You can only have one thing going up or down at a time, which is a big problem. So I actually think now with the rise of reusable rockets, like what SpaceX is doing with Starship, the costs of getting cargo into orbit with, say, something like Starship is about the same as what it would be with a space elevator. And with Starship, you could launch thousands of tons a day, fully reusably. So I actually think the age of the space elevator as a concept is over. We're now in the age of the reusable rocket. And I think that even the age of the reusable rocket will come to an end when we see the age of the space-based manufacturing, resource utilization and manufacturing. So right now, space is just rocks and energy, and everything that's important to us is down here on Earth. But as we launch more and more vehicles into space, as we start to build manufacturing and stuff from space, which is going to be the cheapest way to do this over the long term, then you have less and less need to launch stuff off of the Earth and out into space. You're going to be able to just move asteroids, melt comets, pull the off-gassing as you vaporize rocks on the moon, gather solar power, et cetera, et cetera, et cetera. And after a while, you'll have chip fabs and 3D manufacturing facilities and greenhouses and all kinds of stuff out in space. And so then in the end, and I don't think it'll be long, like I think we're looking in a couple of decades at the most, we'll get to this point where the only thing that goes to space are human beings and a few like really rare kinds of technology that you just can't find out in space. That as we start to build these factories in space, as the factories build more factories, you get this exponential curve that then everything you need in space is already out there in space, and it's there. It's the cheapest place to get it. So I think space elevators are not really that cost effective compared to reusable rockets, and even reusable rockets will not have this long life in our sort of in the future of human spaceflight. We're probably going to shift back to something that is still reusable, but it's all about safely carrying humans from the surface of the Earth to orbit, where then there's a completely different set of vehicles that are then moving from planet to planet, world to world across the solar system. Matthew Jones. Hello, Fraser. Good to see you back, sir. What is your take on inspiration, and do you think the knowledge we gain will be of any different than what we have been gathering on traditional astronauts? So if you're not aware, SpaceX is about to do a private flight of 4 civilian astronauts in about a week from now. When I'm recording this, it might have already happened by the time we release the video. And they're going to fly on a modified Crew Dragon spacecraft. They're going to fly out to a very high orbit, higher than any humans have been since the Apollo days. They're going to orbit around a couple of times, and then they're going to return in about 3 days from when they take off. And they're going to land, and they will have had an amazing adventure on Crew Dragon. There's some pictures that are going around where they've got this cupola that sort of like a window that they can then poke their heads out and look around out in space while they're flying away from the Earth, which is going to be pretty amazing. What do I think? I mean, it's cool. I think it's a great first step for space tourism, because you're not having to build any space infrastructure. They don't have to go to the International Space Station. They don't have to be trained on how to work with all of the complexities of the space station. They just have to be trained on Crew Dragon. And the thing that a lot of people don't realize is that Crew Dragon is actually really big. It has about double the internal volume of the Apollo capsule. So there's plenty of room for 4 astronauts to be on board Crew Dragon and make this journey over multiple days. I think it's going to be a lot of fun. It's going to be relatively safe. I mean, we've seen that Crew Dragon has worked like a charm all the times that it's flown, and regular Dragon. And so they know how to do this. So I think as a sort of a first step to how do we get humans to fly in space on a private level, this is a great way to approach it. Are we going to learn anything new? Not really. I mean, they're going to perform some experiments, but I mean, there have been many ways that people have performed experiments in space on the International Space Station, all through the various space shuttle missions, etc. But I mean, there's always a backlog of experiments that people would like to try, so I'm sure they're going to be busy working. But I do like the idea of flying higher and testing out new ideas. And so, it's crazy to think that we haven't been beyond low Earth orbit in almost 50 years. And finally, it took SpaceX and this crew of private astronauts to make this specific journey. And so I do think that it makes a lot of sense, and I'd like to see more of it. I'd like to see more complicated tasks, go a little higher, spend a little longer in space, try doing some things that will contribute to the long-term survivability of being in space, refuel, do a spacewalk. You can see how if they start to tack on additional tasks, that it will start to teach us some very useful knowledge and skills that we haven't really built in 50 years. So there is a path forward, but I mean, this is really just an adventure for 4 lucky people, and not necessarily a meaningful step to human space exploration. But, every step counts, I think. Giro the Hero. If we are successful at making a base on the dark side of the moon, would it be feasible in the future to make a base on the dark side of Mercury? All right, so I think I need to do a little bit of editing to your question. So, I mean, people talk about the dark side of the moon, but there is no such thing as the dark side of the moon. Every side of the moon is equally illuminated as it goes around the Earth. It's just that we have the near side of the moon and the far side of the moon. Sorry, Pink Floyd, your astronomy is wrong. And the same thing goes with Mercury. Mercury is turning as it is orbiting around the sun. And so every part of Mercury is illuminated. But there are places on the moon which are in eternal shadow. If you go to the poles of the moon, you've got these craters where the moon is essentially turning with respect to the sun, but the sun's rays are never getting to the bottom of these craters. And so they're in eternal darkness. And you've got mountain peaks that are in eternal sunlight. And so you will always have sunlight at the top of various mountains, and you will always have darkness at the bottom of these craters. And you do see the same thing on Mercury. And so on Mercury, there will be these mountains that are in eternal sunlight, good place to put solar panels, and you'll have these places which are in eternal darkness. And so in theory, you could put a base there and to be able to survive. In fact, there's a plan for a mission to Mercury, a lander, because we've never had a lander for Mercury. And the idea is to land on Mercury and stay on the shadowed side of Mercury. And so I say that Mercury does turn. It turns very slowly. And so you have dozens of days of complete darkness on Mercury. So you could land on Mercury where it's cooler and survive. And then maybe you have like a nuclear thermal generator as your power source. And then the rover would crawl around on the dark side of Mercury, and as Mercury slowly turns into the sun, and then you've gotten all the science you're going to get done, and then you have dawn, and your rover fries in the terrible radiation. So yeah, I think it's a good way to utilize this weird orbit of Mercury to get the job done. Greg Rumscheit, do you think that dark matter is tiny black holes? So this is one of the theories to explain dark matter, which is, of course, this mysterious matter that is spread around the universe. It's the vast majority of the matter that's out there. Up until this point, astronomers have like two main ideas. One is that it's some kind of particle that doesn't interact with regular matter, and so it's producing gravity, but we can't see it through electromagnetic radiation. The other idea is that it's the force of gravity working in a way that we don't understand at vast distances. But at this point, the sort of most of the evidence is really leaning on the side that it is some kind of particle, like some sort of massive particle that doesn't interact with regular matter, doesn't even interact with itself. And so one candidate particle that you could use is a black hole. Black hole doesn't shine with radiation. Black holes can collide, but in general, they have to get very close before they're going to actually collide with each other. And so astronomers haven't been able to rule out the idea that they're black holes. Now, you talked about them being tiny black holes in your question, but they don't need to be tiny. They can be tiny, or they could be 1,000 times the mass of the sun. And anywhere in between, there's different versions of counting up the total number of black holes. You could have like just a few really heavy black holes or a lot of really light black holes, and you would still be able to answer the problem of dark matter. And astronomers haven't been able to rule this idea out. But the idea of them being tiny black holes, because Hawking knew or has worked out that black holes should evaporate over time, that any of the black holes smaller than the size of an asteroid, of a small asteroid, should have evaporated since the beginning of the universe. And so you wouldn't be left with these teeny tiny black holes. Although, I mean, something with, say, the mass of the moon compressed down would be a very small black hole. But that these could be wandering the universe, randomly running into planets, stars, each other, and they could answer what dark matter is. And so astronomers have actually done some surveys to try to confirm whether or not this is a real thing. And the most powerful way to do this is this technique called gravitational microlensing. And so what astronomers do is they look at a galaxy like Andromeda, and they watch the brightness of all the stars of Andromeda all at the same time. And they're looking for any stars to wink, and the winking will happen, or any stars to essentially appear out of nowhere and then disappear again. And that's because you get these, within Andromeda, you're going to have all of these stars that are lining up with each other perfectly. And when they do, the foreground star acts like a lens for the background star. But in this case, if you get a black hole, the black hole could be in the front and the star could be behind, and the two could line up perfectly. And now the black hole acts as a lens for the star that's behind it, making the star really bright. But there would be no foreground object that you would see. And astronomers have actually found some evidence that there are some number of these intermediate mass black holes located in other galaxies. So they still can't rule the idea out. But if you ask most astronomers, they don't think it's true, but they won't rule it out. Joe, when we look up, why does the Milky Way only cover one side of the sky, not both? I'm not sure what you mean exactly, but when you look up into the sky and you see the Milky Way, you can pretty much see the Milky Way all year long from pretty much any part of the Earth. So here in Canada, for example, I'm in the northern hemisphere. I'm located about the 49th parallel. And for me, the Milky Way appears as this cut across the sky the heart of the Milky Way, the Sagittarius region, is seen to the south for me in the summertime. So in the summer, I can look to the south and I can see where the center of the Milky Way is. But then you still see the bands of the spiral arms on both sides to the east and to the west of the Milky Way. But you can still see the Milky Way in the wintertime as well. And so just imagine it, right? In the summertime, you are looking, where the Earth and the sun are positioned. Essentially, the sun is located in the outer spiral arms of the Milky Way from your perspective. And so you're on the Earth, and at nighttime, you're looking towards the core of the Milky Way. And then during the wintertime, now the sun is located in the middle of the Milky Way. It obscures it from your view. You can't see it. In daytime, the center of the Milky Way is up. But at nighttime, you're looking out through the outer rim of the Milky Way. And you can definitely see it. And so you can see the Milky Way pretty much every clear night. It's just that during the summertime, it's a lot denser because you're looking into the core of the Milky Way, while in the wintertime, it's a lot more sparse. You're looking out of the Milky Way, but you can still see it the entire year. Darren Clark, how do astronomers know how much a star weighs just by observation? That is a fantastic question. And the truth is that it's very, very difficult to know how much a star weighs if you're just looking at one star. And so if you're just looking at one star, you're kind of guessing based on what the star is made out of, how much energy it's producing, and sort of what kind of a classification of star that it is. If you see a red dwarf that's putting out a certain amount of light, then you know that it probably has 50% the mass of the sun, while a very blue star that's putting out a very hot kind of light could be 2, 3, 4 times the mass of the sun. And in fact, just this idea of knowing how much the mass of something is a really tricky problem when you're looking at something by itself. The way you can calculate the mass of an object is when you can see it in some kind of gravitational interaction with some other object out there in space. And so if you're seeing, say, a binary pair of stars that are orbiting around each other, by calculating how long it takes for them to orbit around each other, that tells you with precision the mass of the two objects. And this was a calculation that I think Newton first came up with and is used all the time. And so whenever astronomers are trying to figure out the mass of something out in space, they're looking for some orbit that it is going through, whether it's got planets going around it, whether it's got a moon, asteroids going around it, some way to calculate the motion of multiple objects. That's what tells you the mass. But if you're looking at something just by itself, it's really tricky to do. You have to use secondary methods. Linda Williams, I'm sure you've answered this before, but I've been wondering lately, what would space look like to the human naked eye once we have escaped from our local galaxy group? Dark? I mean, this is a question that people always love to ask, and I have answered this several times, and I've even done whole videos about this idea, that we are spoiled by what space looks like because we're always looking at pictures of space that have been taken with a camera that is doing a very long exposure. So our human meat cameras, they are gathering up photons for maximum, say, 10 seconds, and then they're throwing out all the photons. And so when you're perfectly night adjusted and you're looking up in space, you're seeing what your eyes can do with a 10-second exposure at best. While when you're looking at pictures of galaxies and nebulae and things like that taken by camera, you could be looking at minutes, hours, days of total exposure time onto whatever medium they're using, film or CCD, etc. And so it's not fair to look at a picture of the Orion Nebula or to look at a picture of Andromeda and think, boy, if I could just get closer, then it would look like that with my eyes. And in fact, this is a mistake that they always make with science fiction. The spaceship is cruising beside some nebula and you got these beautiful nebula features all around them. You wouldn't see any of that. You would at the very best see a slight fogginess, haziness around you. And so think about the Milky Way, of course. We are trapped inside the Milky Way. When you go out at night and you look up into the sky, as we talked about earlier in this episode, and you're seeing the Milky Way, you couldn't be closer to the galaxy, right? It is The center of the Milky Way is only 26,000 light years away from you. And still, you have to have very dark skies, have no light pollution. You got to let your eyes adjust, and then you can see this kind of milky, cloudy band across the sky, but you can't make out the stars, etc. Another example of a galaxy that is quite big, several times bigger than the moon, actually, from our perspective, is Andromeda. And yet, once again, you got to have like very dark skies. You've got to be able to know exactly where to look. And with your eyes, you see this sort of just this little fuzzy cloud in the sky. And you're like, oh, that's Andromeda. And you can't see any of that detail. It's only when you are recording the image for a very long period of time do you actually start to see all of that really delicate structure. And so, unfortunately, for pretty much all of this stuff, you can't make it look better, no matter where you go. If you get close, if you get to just a perfect perspective, it will never look any better than it does from here on Earth. Now, there would be sort of a sweet spot, like you could get to, say, 1,000,000 kilometers away from Andromeda and be directly overhead, and you've got your telescope set up and a really nice long exposure photograph that you take. That would be perfect. But without a camera, it's never going to look good for just your eyes, which is really sad. But it just means, like, don't go to space. I mean, don't fly to other star systems hoping to see nebulae better than you can see them from here on Earth. A.V. Scott and Flower, when will James Webb launch? Oh, zing. We get this question, I believe I've been answering this question for close to a decade now. When will James Webb launch? December 18th, 2021. So about 6 weeks after the original October 31st launch date that we were planning on, James Webb will launch. And I know, like, you're like, oh yeah, tell me again, Fraser, you're going to pencil this in lightly into your calendar. But at this point, James Webb is bundled up. It's being put on its cargo vessel. It's going to be sailed down to the launch facility. All of the parts of the rocket have started to arrive at the launch facility in Kourou, French Guiana. So most of the big uncertainties are all, like, if there's a problem with James Webb, it's folded up into its shipping container, and that problem is in there somewhere, and no one's going to be able to find it out. They've done as many tests as they can do. They've jumped through every single hoop and hurdle, and so now it's just a matter of hoping that all of that engineering work that they did is going to work out. There were some problems with the Ariane 5 launcher, but now Ariane feels pretty confident that they've gotten to the bottom of this. They've solved those problems. So James Webb is done, on its way down to South America. The Ariane rocket, its problems have been worked out. The parts have coming together. So I feel pretty confident that we're now looking at a fairly solid date for James Webb launching. But I mean, like, it's hilarious now how long things take. So who knows? And of course, when it's actually stacked up on the, like, would you press the button to launch James Webb, or would you say, like, oh, just like one more test? Let's just try one more. Let's just check this. Oh, the weather's a little dicey. I think I want to hold off another week just to be safe. So who knows how many more delays once it's actually, because I'm sure they're gonna wait for absolutely perfect weather. They're not gonna take any chances. James Webb must fly. There is $10 billion of money and mind power and scientist expectations bundled up into that rocket, into that mission, and so it's got to be successful. Oh. And just like here we are now in September, but I'm just imagining what it's going to be like when we're in December, after it launches even, and it then is going to spend a month unfolding, and every single actuator's got to work perfectly. Like, I'm not going to get any sleep. It's going to be terrifying. Gitmo Holiday. I have a question about balloons. Would it be possible to use a hot air balloon on Mars by heating up carbon dioxide, and the density difference would make it float? Yes. A hot air balloon would work really well on Mars. In fact, there have been several missions proposed to do exactly what you're talking about. Now, the challenge comes that during the night on Mars, temperatures can get very cold, 100 degrees below zero, while during the daytime, it can get reasonably warm. You can have the temperatures be, say, even up to 10 degrees centigrade. So the idea that was proposed is that you would have a balloon that would be fully inflated and would rise during the daytime on Mars. And then it would have this cable below and an instrument package that would be riding below it. And then during the daytime, it would inflate and it would rise up off the ground and it would float on the air currents. And then at nighttime, it would sink back down and then it would just sort of rest. You sort of imagine a partially deflated helium balloon that you've had from a party 2 weeks ago. And then the string would be sort of hanging, the cable, the instrument package would be lying on the surface of Mars, waiting for daytime again. And the day would come, and then that would warm up the temperature, that would increase the volume of the balloon. It would rise up again, and it would fly again. And so it's a pretty great idea. Of course, you can imagine some of the technical challenges, like having your instrument package have to slide across the Martian landscape every night as it's lowering back down. And so I think, when we look at the incredible success of Ingenuity, that's the way Mars is going to be explored by the air. I mean, it's been such an incredible success. And you can imagine a future mission going with like an aircraft carrier, bringing along dozens of these helicopters, just dropping them out into Mars at various points. And then they all land. And then they all just wait, collecting their sunlight, and they lift up and they fly around, and then they land and they gather more sunlight and they just go. They're inexpensive. They are clearly very, long lasting. And so I think it's a great idea. But if you want like a heavier instrument payload, the balloon idea actually is a pretty good one. And we did an episode about that a couple of years ago, but yeah, I think it's a terrific idea. I would love to see someone try it. A balloon on Venus obviously is sort of the right place to take a balloon mission, and hopefully we'll see something using a similar technique, something that can change the volume of the balloon to go higher and lower in the altitude of the atmosphere. But I do love the idea. All right, so those were the questions this week. Thank you, everybody, for jumping in the chat on the live stream, asking your questions, as well as all the people who ask some questions in the comments. I love to read through them. I love to answer them. So we'll be back next week with more questions. Thanks. If you want a single comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks, as always, to all the moderators, and a special thanks to Chad Weber and Nancy Graziano.